Hello, this is Mr. Best. Welcome to section 1.4, Transformations. We're going to talk about how to graph a lot of different functions based on vertical, horizontal shifts, reflections, and non-rigid transformations, stretches, and compressions. First off, we just need to know some things about our common functions. I have 6 of them up here. Now, these are not the only ones we know, but ones we'll be working with. First one is quadratic. Anytime you guys go and graph the parent function, you want to graph the most basic part of that function. So with a quadratic, it's just x squared. I already have all these plotted, but they're not memorized or anything. You're just plugging in points. So 0 squared 0, 1 squared 1, 2 squared 4, 3 squared 9, and then you got the left side as well. With a cubic, you have x being raised to the 3rd power, so same thing. Plug in 0, plug in 1, 2. That one's going to go up a little bit quicker. And then on the negative side, it's going to go on the negative y. With the square root, our domain's restricted here, so we only start at 0. That's the lowest value. And then from there, I plugged in 1, 4, and 9 because those were my perfect roots. On the cubed root, this is the inverse of cubic. So you can actually see the graph just reflecting across the line y equals x. And so now I plug in 0, 1, but now I want to plug in 8 because the cube root of 8 is 2 and the cube root of negative 8 is negative 2. So you can kind of see that rotation there. Absolute value, f of x equals the absolute value of x. So when you plug in any number there, that's once again your most basic absolute value. You plug in any number, you're going to get the positive of that back. And then rational, this is where we're eventually going to get to. I'm not going to worry about too many transformations of rational, but it is 1 over x, so you do have this restriction. Let me go ahead and graph it so you can see it. But we do have a vertical and an actual horizontal asymptote, and we'll get into all this stuff later. But this one's a little bit harder to graph. There's not very many values of x, so I'll sketch it. It's not going to look too pretty, but it's kind of what you're looking at. That top one's a little rough, but that's rational. So that one's going to be a little bit more challenging to do transformations on, but it's still possible at least to describe what those transformations are. So those are the parent functions that we're going to most deal with. We could do this, and you guys did. If you've taken trig, you've done transformations with the trig functions as well. So we're just going to go through the different ones here. Translation is a vertical or horizontal shift. So when I think about these things, I think about what is changing. So with a vertical shift, think about vertical. You know, you're going up and down. So what's changing when you go up and down? The y value. So you can see that f of x, when you add something or subtract something from the y value, which is the function, then the graph shifts up if you're adding, and it shifts down if you're subtracting. With the horizontal, alright, now we're going this way. So what changes when you go horizontal? Your x value. So look at the change that has occurred. So now when you shift right, it's x minus c, and that c is actually positive. It's just x minus positive c. And then when you shift left, it's x plus c, and the reason, once again, it's actually x minus negative c. And so if it's x minus a negative c, then in the equation you'll see the plus c. But it is shifting to the left, and the c value is negative on that as well. So just to kind of apply a couple of those translations here. If I can get all this on the screen. Maybe not. Alright, I think I'm going to have to give up. There we go. Alright, so I have the parent function x squared already graphed. Now I want to do x squared plus 3. Well, what is this plus 3 being added to? Is it being added to the x, or is it being added to the y, which is the function? It's being added to the function f of x, which is x squared, so your y is what's changing. So that means this is going to shift up 3 units. So you're going to take your parent function from here and shift it up 3 units. So all of those points get shifted up 3 units. And then I'm only going to get 5 of the points because the other ones got shifted off the graph. So here is my quadratic. Didn't realize how hard it is to graph on here. But there's my quadratic being shifted up 3 units. Well, what's the difference on the next one, g of x? Well, it's x plus 3. So what's happening? Well, it's really x minus a negative 3. So this one is going to the left 3 units. And so once again, we're taking your parent function and shifting it left 3 units. So now my vertex is at negative 3, 0. But then the shape of it stays the same. And we're shifting all those points left 3 units. So you could graph the parent function and then shift the points left if that's easier. I'm sorry about my graphs. So that's translations. And like I said, those are really just your vertical and horizontal shifts. You're not changing the shape, you're just moving things around. Okay, here's a couple more if you just want to look at them. We got an absolute value. I changed the functions a little bit so you could see the difference. We got an absolute value, x minus 5. So what's changing? Once again, is that changing the x or is that changing the y? Well, it's changing the x. So this would be a shift to the right 5 units. On b, is this plus 2 being added to your function or is it being added to your x? Well, it's being added to x cubed, which is your function. So this one would be shifted up 2 units. And then the last one, there's 2 things going on. The x minus 4, that's changing the x, so that's going to the right 4. And then the minus 1, that's being added or subtracted to the entire function of x squared, so that's also going down 1. So it's going right 4 and down 1. And so, for example, let me just kind of pick one of these to graph so you can see. Go with b. The cubic, if you remember cubic, plug in 0, you get 0, plug in 1, you get 1, plug in 2, you get 8. So I'll go ahead and graph the parent function so you can see it. And then I'm going to change colors. And then I'll graph things being shifted up 2 units. So about 2. And so now the blue one, and it's going to be very close together, especially me trying to graph on here, but the blue one is your new one. And so hopefully you can do a better job on paper than me, but that's what you're looking at. And so the same thing for A, you would take the absolute value parent function, shift it to the right, and then on C you would do 2 things. You would go to the right and down 1. So on C, if you do it, I'll just show you the new one. If I go right and down 1, there's my new vertex, and then here would be my other points. And once again, since the shape on this one's not changing, I'm really just using the parent function at my new vertex to do my counting, because I know it's 1 squared is 1, 2 squared is 4, and 3 squared is 9. And there you go. So there's some translations. The next thing that we're going to look at are reflections. We can reflect over the x-axis. Once again, I got my parent function of x squared. Here's going to be the question again. Is the negative with the x or is it with the y? Well, if you look at these, if you reflect over the x-axis, okay, these negatives, when you reflect over the x-axis, once again, think about this. Here's your x-axis. If you take a point over here and reflect over here, what is changing? The x is what's changing. If you're moving up and down like that, this point we'll just call a b. This point is now a negative b. So that's what's changing. It's the y value that's changing. It's not the x when you reflect over the x-axis. So that means the negative, when you reflect over the x-axis, must be with the function. So look where the negative is on those two examples. It's with the x squared. It's not with the x. You first square it, then it's the negative. Okay? So when you see that, you're going to reflect over the x-axis. So once again, here's my quadratic. I'm going to take this and I'm going to change it to reflect over the x-axis. So the point 1, 1 becomes 1, negative 1. 2, 4 becomes 2, negative 4. 3, 9 becomes 3, negative 9. And same thing on the other side. That was almost a good one. And then when you add stuff to it, you're adding 3. Now when you go to do this, some people think maybe the order matters. Well, it depends on how you look at it. If you're going to shift up 3, okay, you can't shift up 3 and then reflect over the x-axis, okay, because you've changed your line of sight. You've shifted up 3, which means you've changed your line of reflection to also up 3. So if you do shift up 3 first, which is fine, then your line is now, your x-axis got moved with it. So that's now your line of reflection. Or you can just reflect across the x-axis to begin with, and then shift up 3 from there. So we'll take the origin, which is 0, 0. We're going to reflect over the x-axis, which means it stays there, and then we shift up 3 units. So there's going to be our new vertex. The point 1, 1, which was right here, we're going to reflect over the x-axis, which would now be right here, and then shift that one up 3 units. 1, 2, 3. Okay? And remember, the shape is still the same, so that in terms of a quadratic, when you go 1 over 1 up, now we're going 1 over 1 down. So once you get that vertex, you really can just create that shape. So I'm going to go 1 over 1 down. I'm going to go 2 over and 4 down. Same thing, 2 to the left and 4 down. And then when we took 3 to the second power, we got 9. So now I'm going to go 3 over and 9 down. So right there and there. And the nice thing is, because the shape doesn't change, if you find that vertex on a quadratic, you have it, so kind of on the bottom here, if h of x is a reflection over f of x over the x-axis, then h of x is equal to negative f of x. Once again, that negative is with the function because the y is changing. Alright, I want you guys to think about these things. I'll talk about this more in class, but I really want you guys to think about this and not try to memorize it. That's why we get confused with the negative signs. Because take a look at the next one. So the next one we're going to reflect over the y-axis. Alright, so what's the difference? Well, when you reflect over the y-axis, so now we're going this way. Alright, if you reflect over the y-axis and you take a point here and reflect it over here, what changes? Once again, it's not the y that's changing, it's the x. This is negative a comma b, and this is a comma b. Okay, it's not the y that changed, it's the x that changes. So now when you look at this, look at the sentence down here. If h of x is a reflection of f of x over the y-axis, then where should the negative be? It should be with the x, because you're reflecting it and the x is changing. So when you take a look at these, we're doing the square root of x, and I'm going to have to pause because someone just showed up my house. So I have to create 2 videos. Sorry. I'll pick this up in just a minute.